Okay. So, hello everybody. My name is Ahmed Ragab. I am a research scientist in the domain of artificial intelligence, working for the industry group of CanmetÉNERGIE at Natural Resources Canada. I am also an adjunct professor at Polytechnique Montreal, and I'm here today to talk about the digital twin developed by our team for energy efficiency improvement in a paper machine in the pulp and paper industry. Uh, in the beginning, I would like to give a quick overview about our team at CanmetÉNERGIE and our focus. We are a multidisciplinary team of 14 people composed of engineers, scientists, software developers, and PhD students. Our main expertise in artificial intelligence, machine learning, process engineering, modeling, simulation, real-time optimization, decision making. We have also transferred knowledge to industry and trained and provided technical support to engineers in different industrial sectors. We have developed the software Explore and other AI solutions that are used extensively by many industrial sectors to perform data cleaning, preparation, and modeling. We use these tools to develop digital twins for energy efficiency improvement in industrial processes through different applications, including abnormal event diagnosis, prognosis, supervisory control, condition-based maintenance, etc. So here we are talking about our proposed approach. Uh, uh, we talk about active digital twin, which means that the twin interacts with the physical system in real time, adapts, simulates scenarios, and propose actions. Our approach is to apply these digital twinning concepts to process industries, but we are trying to apply it to the whole supply chain. We take first supply chain here as an example to explain the approach. However, we are targeting other sectors such as the steel industry, oil and gas, mining, and others. So as you can see here, starting from the first company, in the sense of its chain, we start collecting all available data such as IoT, sensory data, economic data, etc. And this data must be integrated, pre-processed, and fused to develop digital twins for physical elements that make up the chain, such as harvesters, machines, equipment, processes, factories. And these digital twins will be used for different applications, such as optimal asset management, planning and scheduling of operations and product and equipment design. So as you can see here, these applications interact and integrate with each other to maximize the impact of the proposed approach along the value chain. To develop our tools, we mainly rely on open software packages implemented in Python and other programming language, and we are also using some commercial software packages. And all these diversified platforms are used for connectivity, data preparation, modeling, simulation, and visualization. So we started with the digital twin of paper machine as use case in the first value chain. It's really a complex and energy intensive equipment. The objective is to minimize the specific steam consumption through real-time optimization and automated inefficiency diagnosis. And the machine has three sections. And to develop digital twin for this machine, we define three KPIs, and we group them into global KPI, which is the steam consumption. It's defined as how much steam we consume per ton of produced paper. So we have to respect some constraints related to the quality and properties of the produced paper. So we acquired the data from the mill PI system, and we cleaned it to develop AI algorithms that make up the digital twin. And we have developed a graphical user interface that allow the operator to have access to the status of the paper machine. And this interface consists of three windows used for fault diagnosis and corrective measures, KPI monitorings, and optimization. This digital twin was tested during 3 months of operation in an advisory mode, and we have evaluated the potential impacts in terms of energy savings and greenhouse gas emission reduction. And the real impact depends on the action taken by the operator, and these real impacts will be evaluated in the near future. So now we are good at improving the energy efficiency by optimizing the operation of equipment and units. But we want to further push to maximize the energy efficiency at the plant and the value chain level, taking into account the existing forest resources as well. So as mentioned previously, our approach involves several developments that are connected and integrated. We are working on supervisory control, prescriptive maintenance, operation, and production planning right now. And also we are working on the design of product and equipment. And I will briefly give you an overview on the supervisory control and prescriptive maintenance tool that we are developing right now. So we have started the development of intelligent tool that combines human expertise with digital twins and simulation-based optimization. And this tool uses the event log to better understand the behavior of local controllers. And we used the reinforcement learning as a decision agent to recommend the optimal controller set points that maintain the desired process operation. And currently we are testing it on a thermomechanical pulp mill process. And our plan is to test the tool on the paper machine to address several control issues such as control loop tuning and improvement at the PLC and DCS level. And we are also working on the second tool, which is the prescriptive maintenance. We have started the development of this tool using digital twins, prognosis models, and causality analysis. The aim is to monitor and diagnose complex equipment conditions in real time and to predict the time of occurrence of abnormal events such as fouling, corrosions, and also we aim to prescribe actions. I mean, this tool can prescribe actions for operations and maintenance to reduce the risk of failure. And we have developed a precise prognostic model based on LSTM, and this model was tested successfully to forecast the level of fouling of an evaporator in a kraft mill. And the next step is to develop the maintenance scheduling model for cleaning the evaporator. And now I would like to summarize and share with you some lesson learned and key challenges that we have faced when developing and implementing this digital twin. We successfully developed it on the paper machine to improve the performance, and we faced some challenges mostly related to the lack of experience of operators to deal with AI and database techniques, particularly in the pulp and paper industry, as you know. And also the involvement of the mill staff in the development phase is crucial. We believe that combining domain knowledge and machine learning is crucial for the development and implementation of digital twins. And also avoidance of intrusion of the tool in existing control system helped us and helped for the acceptance and implementation in the mill, since we are developing it in advisory mode. And that's it. And thank you for your listening.
Thank you for this presentation, Ahmed. I must say, I'm honestly a bit surprised that forestry is such an industrialized sector. I mean, I should have known, but I wasn't aware. So but this was super interesting for me. I was wondering, for the digital twin that you developed for the pulp and paper mill, you said that you could prove the efficiency improvements and that the acceptance by the mill staff was quite good. So what are going to be the next steps? Are you planning on like actually like connecting the digital twin directly to the control system?
Yeah, actually, we connected we connected it to the mill. It's already connected. It's already connected, and we have access to it from our lab at CanmetÉNERGIE.
And it works.
Yeah.
Wow.
If I may add something, Mulud speaking. Hello, everyone. For now, as Ahmed said, it's in supervisory mode. It's for decision support. So it's implemented in the mill. They're looking at it. They are trying to get, to understand very well how it works. And I think it's going to take some time before we connect it to the control system. We are not there yet.
Yeah, it's in advisory mode.
But the purpose is probably later on, especially for the diagnosis side. Maybe for the real-time optimization, it's going to take more time. But for the diagnosis side, to diagnose inefficiencies, I think this will come quite soon, I would say.
Wow, this is really advanced. Say, what kind of suggestions does the system make to the operators?
As I said, it detects and diagnoses inefficiencies or quality problem, and it proposes an action to correct the situation. For now, the operator should change the set point by himself. For now, but of course, I think it's always better to go through this the step that let's get them, look at it, how it works, and try to evaluate the performance of the tool. But I think it's going to come from them, not from us. Once they are, they are ready to do it, they're going to do it.
Yeah, sure. I mean, this has also been one of the takeaway points from the other presentations that we've heard so far. So this seems to be the way that digital twins are established. And I mean, if your system is already making very specific suggestions, like tune up the set point or tune down the set point, then it's just a little step to like closing the loop and making it fully automatic. It's really advanced stuff.